upload to the YouTube channel of PyCon Hong Kong. Yeah.
Great. I just started the recording now. Yep. All right. Hi, everybody. Thanks for joining for the the Python session, the GraalPython. Just give me a sec to share my slides. Sec. All right. If there's anybody who's not on mute, I mean, can you see my slides as well as the presentation?
Yes.
Okay, great.
Yeah.
Okay, thanks. Yeah, I was just going to give it 5-10 seconds for, I know there are a couple of sessions going on, so very exciting. And I want to say thanks to Sammy for setting this up. Always nice to be part of your session, so thank you. And over the next 20, 25 minutes or 30 minutes, I'm going to be sharing a little bit on an introduction to GraalPython. So the idea here is that, previously, you might have heard, or how many of you have heard of the GraalVM project? I guess just to, before I mention GraalPython, has anybody heard of GraalVM? Okay, great. So I do see some people raise hands. So that's cool. So this is, the idea here is in terms of polyglot, so multilingual, multi-language support via a one processing system at high performance. So you get the benefit of supporting multiple languages running on one virtual machine with improved performance and areas like that. So what I'm going to be doing today is sharing some updates, as well as then also running through some demos that I put together, showing interoperability between these languages and things like that, right? So just a safe harbor statement, looking at forward looking. So there's a lot of different areas Python is being used within Oracle and as well. So on the cloud side, where we have things like Python for Ansible, utilities, also on the database side, analytics. We've got things where we're doing some machine learning stuff, and also on the application side, as well as the application server and Solaris side. Focus today is more on the GraalVM plus Python, which is what we call GraalPython, right? So what it is, and how it can benefit, what's the status of the project, and also what are some of the things that we're looking at going forward. So what is GraalVM, right? So basically what it is, it's a compiler and a runtime, right? And also a polyglot engine, 3 things put together in one virtual machine, right? So it's running as a next generation VM. So what it does is it supports multiple languages, and it can run it fast via a single runtime, right? So the focus today is kind of showing you more on these lightweight interpreted Python support that we've got. And what you will be seeing is interoperability and also multilingual support between some of these languages. So GraalVM is what you see on the bottom, and you see the set of JVM languages and these lightweight languages, and also LLVM bitcode, so that you can also have interoperability with C, C++, and also Rust as well. There's some newer ones like WASM that I didn't really update it in there, and so forth. So in a nutshell, the GraalVM architecture has Truffle, for high performance multilingual switch, what we call context switch, executable VM environment, so that it actually runs on top of the hotspot, and we have a compiler interface layer, and you can see the compiler and also the Truffle framework. So what you see here is the Python interpreter, right? And you will start seeing how we're running applications together with, Python applications in GraalPython mode, and what are some of the things that it supports, things like, NumPy, Scipy, and scikit-learn, and so forth, right? So GraalVM obviously has some good performance, and across Java, Scala, and also other languages. So I'm not going to spend too much time on what are some of the other languages, but we have comparative support and also better language support in terms of performance across some of these languages. So there have been papers published on this accordingly on the industrial committee and so forth, and you can read about it. Now, going back to GraalPython, this is particularly an interpreter that is written for Python 3 implementation. So the one you're seeing today is for 3.7.4. And at the moment, it's early stage experimental, meaning that there's an implementation of Python. So ultimately, we will have full compatibility down the road for Python 3.7, and aim to have full support for Scipy, and other dependent libraries like NumPy, Pandas, scikit-learn, and things like that as well. So you'll be seeing some demos of Pandas and so forth today, as I'll be showing you as well, right? So that's the idea. So the first aspect today is just showing you how to actually install it and run it. So it's actually quite easy. All you need to do is just go to the website and run that. Let me just share my full screen here. Just give me 1 sec. While that's being done, the best way is for me to just share my desktop. That'll be easier to see the different types of share my desktop. Okay, that's great. So I think you can see my desktop now. So the best way is, if you want to set yourself up with GraalVM, the best way is, you go into the reference manual section for graalvm.org and Python. And the 3 main things that you need to do to set, a GraalVM up, Python up together with GraalVM is obviously, one is you need to download GraalVM. Just download GraalVM. Everything is within GraalVM. And then what you do from there is you do a install of Python. So you do a GU install of Python, and then you can start running it, right? As simple as that. So the 3 things that I do for some of the support packages is that I set up the virtual environment for GraalPython. And one difference is that instead of pip, you're using GI install, right? G install and so forth. So then you have a source, and then you do a G install, and you can start running your, for example, your pandas and things like that. So it's basically like 2 or 3 lines in there and so forth. So it's actually all mentioned in this reference manual and stuff like that. So that's on your GraalPython install, run, and things like that. So what I'm going to be sharing basically is some of the results that we had almost about a year ago. And I'm going to be doing some real-time results right now to show you how much improvement we have seen over the 1 year and so forth, right? So what we see is that previously when we ran some of this GraalPython performance measurement and things like that, we saw and we ran some benchmark scripts, right? So some of these benchmark scripts were using, different types of, Monte Carlo methods and so forth. There were some, 2 benchmarks that we actually used. So what we did was we compared CPython, Jython, which is Java Python, and PyPy, and also GraalPython, right? So what we called, at that time, we used the community edition. We ran it on a cloud infrastructure, basically, right? So then after that, we realized that there was different types of implementations, obviously Python implementations, right? You have CPython, Jython, PyPy, and so forth. And then there were different versions. So this is from a year ago. So the versions have now obviously progressed and things like that. And then the standard available Python versions and also the features accordingly and whatnot, right? So this is what our benchmark was based on. So the GraalPython performance benchmark was using 3 different scripts. One is what we call a PyPerformance. It's a modified executable library. So the first one was Spectral benchmark, where the script was to, for example, solve $100, 100-digit challenge programs. The other one was on a n-queens problem, which was basically to solve at a simple solver. And the third one was like a game script, which is for a computer language benchmark and so forth. One of them was actually even for the written by some of the folks at some of the laboratories and also universities and so forth. So what we saw was that comparatively, when you looked at GraalPython versus the rest, there were improvements. So it outperformed PyPy and gave a lot of better performance than CPython. And in some of the packages and all that as well. So we also saw equivalent performance. And then in other areas, there were, say, for example, in the Queens, we start seeing that the execution speed of CPython was slightly better than the standard implementation and so forth. So I'm going to try to run that same benchmark that we have got. And I'm going to try to do it here. Actually, I just ran that same benchmark. Can you actually see my screen here, the blue screen? So what this is this is a benchmark of the 3 different types of, the 3 different benchmarks. So you're running it with Python, PyPy, and GraalPython. So obviously, we're not using the Jython in here. So we're doing it for the 3, and then we're going to be outputting it and so forth. So I ran this about 15 minutes ago. This does take time because you're running a lot of loops and warm-ups and all that. But just to share with you the numbers based on what we saw last year and this year. So this was something that I ran just now. And if I had to compare Python, PyPy, and GraalVM, you can start seeing that the mean time taken for GraalVM in there was about 122 milliseconds. Similarly, when we looked at the Richards benchmark, it was also giving the best mean with a standard deviation of 75, which is at about 6.84. At the last benchmark, it was obviously slower than the PyPy, but let's give it a go and we see what happens over here when we run it live. So this is basically the run all script running those 3 benchmarks, and we'll probably just stop after the first one because it won't make sense to kind of go through so much of the so many of those and so forth. But this is running the benchmark, and let's see what happens and so forth. So that's the first one. I just want to see if there were consistencies between the 2 and so forth. So this is running through the loop, and let's see what happens. Meantime, if you guys have any questions, feel free to post it here on this chat window, or just unmute yourself and share it accordingly and so forth. So it's calibrating, going through a loop, and let's see what happens in that first iteration of this Vankuch benchmark, right? So which is basically what we're looking at is the game script for computer language benchmark over here. So it's running this one here. And let's see what we get from there, right? So it's giving you first the Python results, and then we will start seeing some of the results accordingly for PyPy, and also then for Graal and so forth. So if it is consistent between the previous run of this, we will see, for example, in this Venkuj, this calibration over here is about 133, 122, 160. So let's see what happens here. Curious of that as well. So while that's going on, that'll probably take about a minute or so for us, but it's nothing like seeing a live iteration of it. So I'll let this keep going, and then we'll come back to this as well. So what are some of the other things that we basically look at when we look at this? When we're looking at these performance benchmarks and so forth, we can also do things like debugging and so forth as well. But it's always nice to see numbers. And I think running it live is also is a good way of seeing it. So these are about 34 warm-ups here, and that was for the Richards language. Yeah. Give it a second or so. Some questions there. Oh, okay. Yeah, it's a great question, Kevin. So the best scenario now is, just go directly to the graalvm.org site, download it, and test it, for the workload. So, if you have applications that, for example, here in Python, you keep in mind that Python for GraalVM is still in experimental mode, so support will be getting stronger and better and things like that. But that's not to say that you can't run it already for applications that are written in Java, JavaScript, and so forth, which is already supported accordingly. So those are something that you can run immediately, and especially if you are running it, you want to switch out to a better and more efficient compiler and things like that, because it runs on hotspot. So you're running things on just in time, or you want to create ahead of time native code. It's already being used today, so the customers like Twitter and so forth using it quite a bit, for Scala and JVM type languages and all that as well. So Python is on the newer track, and we've started seeing quite a bit of traction here. A lot of questions we're getting is on the NumPy and Scipy, scikit-learn, and things like that as well. So here is where what we saw. So we're seeing some numbers. So hopefully that answers the question for Kevin. And I'm just gonna, switch out once we see the GraalVM numbers here. So what we've seen so far on the Python side is about 1.22 seconds. We saw the one for PyPy, 72 warm-ups at about 172 milliseconds. So curious to see what happens on this iteration. And from there, we will exit from here. So we're looking at about 182. So it's slightly more than the PyPy, but obviously, a great amount of difference compared to Python and things like that. So there's standard deviation of about 100 on this and so forth. So I'm going to cut it out at that, but that's the basic idea, right? That we actually see, and once we exit from there and so forth, let me just get it out from there. Yeah. So that's basically what happens when we look at some of these benchmarks. And going back, you will start seeing, and I'll share this. So what I'll do is I have a GitHub site, but it's more for some certain code. So I'm going to put this whole benchmark that was run on the site and with the newer download, so you can actually follow through what you actually saw and so forth. So some of the other things that you can see. So I'm going to skip through this and get back to the polyglot part. But I wanted to also share that when you look at performance for GraalPython, and when we looked at measurements for Monte Carlo method, and when we were running some scripts, we're starting to see even for this, there's differences when you compare the PyPy, and the result is obviously higher than CPython and Jython, but sometimes not comparable with PyPy, right? So we saw those marginal differences and all that. So the CPU-bound processes that are using the JVM obviously perform better. So that's where the GraalVM magic comes in. So when you're using it for CPU-bound processes without I/O and things like that, so that's where the optimized calculation comes in and it's beneficial and so forth. Others that we see in the method 2 when we ran this Monte Carlo script and so forth was the kind of processing system where you wanted to have certainly when there were a lot of different types of threads were increased, what happens, and then we saw that Python or Java Python does not support the global the GIL and so forth, and that way it has shorter processing time and things like that. So based on the threads and so forth. So these are some of the Py type simulations that were run using GraalVM and so forth. And there's another one basically to mention to you that for GraalPython and the global GIL, global interpreter lock and so forth. So GIL, as you know, is a protection mechanism that limits the number of threads. So GraalPython uses GIL. However, when we look at PyPy, or rather Jython does not use GIL, and then PyPy uses GIL with certain ways that you can actually avoid it as well. So basically what it can do, it simplifies low-level processing for memory management and so forth. So it uses GIL for multi-thread processing and can be executed by one CPU core as a CPython accordingly. So that's a good thing, right? Another attraction of GraalPython is this polyglot style. So basically, you could code in one language, and then you could call another type of guest language, whether it's JavaScript or Java and things like that. And that's what we're going to be seeing right now, right? So let's do a bit of that on the on this front. So this is a polyglot code. Let me just share the code first, what it does. The code is actually here. So this is a random number polyglot. So this code is basically, this is a whole section of it. So if you can see it. So it's kind of like an algorithm. It's written in Python, simplified way of doing generating random numbers, right? So that's what we see in this RAID and this for loop. And so what we have done there is we have basically taken a snippet of Python code, and the way we are invoking it is we import polyglot. It's a function, as you saw, as part of GraalVM, and that uses the built-in interoperability, and we can actually call an R package to do a plot, right? So then what we do is we create an R function, save it to the Python variable, and finally we visualize it, right? And then we create the R function, draw a histogram, and you should see a graph and things like that. So this is kind of like the polyglot function, and we are importing different types of using different types of Python and capabilities in there and so forth from Graal. So let's run that. So this is the random number polyglot. So this, if you are seeing my full screen, this should come up. So it should also include the rendering of the R plot together with GraalPython. So what we have done is, as you saw in the command here, I've ran it into the GraalPython JVM and then the polyglot flag, and then the whole code string that we saw over there as well, right? So now it should basically give you the p-value displayed over here, and also the output that you will see on this screen. So try not to blink your eyes so that you can actually catch the beautiful plot that comes out from the R mechanism and from Python and R going forward as well, right? So here we go. So this is the plot as it's coming up, and once you see the plot, you'll see a hello from R to GraalPython, Python to R, and basically showing you the total, and then we exit from there accordingly. So that's a beautiful sort of a nice visualization, and you can actually follow that. I'll actually show some of how you can do that and things like that as well. So now you might wonder, if I wanted to do things like debugging of this and so forth, how do I do that? So we have also got other types of code. Say, for example, if we ran a library type of code, which is a function in polyglot programming defined in Python. So here we are going through like a Fibonacci sequence, and then printing out Fibonacci on the 9th iteration and things like that. So when you run that, and we obviously can run it. You will see the result here and over here. But what we're going to do is let's inspect it, right? So we can always inspect it and debug it into Chrome. So when I run it in that manner, I'm able to take this and launch Chrome, and my browser basically go in and run, and you start seeing from there the specific area of the code for library dot, it should be library.code right there. So what happens is you can actually step through and do debugging, and you can actually put specific areas where you want to actually put flags in there, and you can run and do the debugging. So behind the scenes, you can actually do that, and it will actually go through different iterations, as you can see on the bottom, printing out the result, and you can catch that and so forth. So it will be going through those loops and also giving you the results, and you can actually see the breakpoints that you have added, right, accordingly on the right. So you can even do some of the dynamic programming in here. So the key thing here is that the GraalVM is integrated together with your Chrome, and you can actually debug code, interactively using the Chrome debugger from within GraalVM for your Python code in there as well, right? So which is a pretty cool thing, right? So I'm just gonna exit from there and so forth. So some of the other things that you can do over here. So if you're running things like your pandas and so forth, I'm just going to go through some of the pandas sort of capability. So let's go through that area. So where is the pandas area that we've got? Let's see, switch that out to this window. It's running DevTools, okay. So for example, if we had some, you wanted to run in you wanted to have a shell within GraalPython on your machine, and you wanted to run it just as if you're running it. So let me just type, let me show you first. So as you can see here, that's the version, right? So GraalPython, so if you can see it there. So it's showing you that it's running Python 3.74 with GraalVM native, right? So one of the things you wanted to do there is, say, for example, let's go inside a GraalPython shell, right? GraalPython shell, and we'll do an import pandas and so forth. So you can actually import pandas as PD and whatnot. And then from there, let's run maybe some of these series and things like that, right? So just take a while. What's happening? We will be doing want to run some basics, some of these basic operations, just to show you that how you'd run pandas basically in terms of running it with GraalVM and things like that, right? So once that's ready, you'll be able to basically start going through some of these iterations in the shell. Okay, anytime now from here. So these are just some of the things that we're working through and things like that. So pandas official support coming through. So while that's going on, that should be able to there's usually see some other code that is going on over here. Testing code. Yeah, so these are just some of the other ones. So let's try running the, let's exit from this. We'll give it another second while that's happening. Polyglot example. So here's another example of a polyglot code that basically has JavaScript in it. So let's go through that one. Okay, is this one ready? Yeah. So now let's just run inside this pandas. Some pandas logic, like for example, series 1 over there. You'll see a series, PD series. What are the other things that you want to do? Print the series and maybe see the output. And you can do that, and that should kind of give you the output, so it prints the output and all that. So you'll see a lot of that pandas kind of capability that you need, printing series. You can go in and do a lot more of the data frame outputs, and have different integer values being printed and things like that as well. So that's a interesting part. Another interesting polyglot code that is showing you some I think there's also a JavaScript aspect to it and so forth as well. Let's see this one. So we've got polyglot eval running, we've got language, and then we've got a pattern matching. And if the string is pattern matched, what happens? So this is a string that was matched by GraalJS. So we're running and calling code from within GraalVM JavaScript across Python. So when we run this polyglot.example, let's see what happens, right? So let me exit out of here, right? So when we run this code, run this polyglot example code, you should start you basically see that in here that it will have the matching strings and things like that, right? So that should be the output result from there. So that's again a polyglot function mix between Python and then also JavaScript within GraalVM. So that should give you the output accordingly. There you go. So here's what we found. The string was matched by GraalJS and things like that. So that's a pretty interesting one. Going back to the slide, so these are some of the things and other things you can do. Is the attraction of GraalPython is not only just performance, but also the ability to run polyglot applications, machine learning execution, and things like that. Another ones that you can do is like JavaScript. Also, you can do it Ruby and have this ability and no restriction, right, on the server side, that you can reduce the restriction of programming languages, and you can do context search between one and use different analytical models across different types of languages and things like that as well. So there are a lot of interesting things. I mean, you can also run Polyglot in a shell-like format. For example, within over here, if I wanted to run Polyglot in a what you might call a shell, that's pretty interesting. Let's see that. It will open up an interactive shell, which is a polyglot shell. So in this polyglot shell, we're running GraalVM with all the different types of languages that we have turned on, right? So if you wanted to switch to, say, for example, Python, so what we could do is Control L, and that should basically switch to JavaScript to your Python, and then in that Python environment, you could do whatever you wanted to do, like things like your calculations for Python, 1 + 1, whatever it takes. So I mean, 1 + 1 and whatnot. I mean, all these things, basically in Python, and you want to be able to, just to test, print hello, and just those kind of things. So all that, basically you get those kind of capabilities with you. And so let me Control D out of this, Control D, and I'm out of that, and so forth. So these are just some of the things that you can do from within the polyglot shell, and it's pretty interesting. So this way, what happens is, you're able to see some of the performance benchmarks. You're able to see some polyglot code that has been running, where you want to be able to run an R package in Python. So since you're a citizen of GraalVM, you have all this interoperability. You can run Python libraries from within R, as you saw that nice invocation. And there are a couple more things that you can do accordingly and so forth as well from there. So that kind of is, some of the areas that to update you on where the status of the GraalPython. It's currently experimental, but it performs better than CPython. As you saw, pretty close to PyPy, even sometimes faster than that as well when you look at the benchmarks that we ran recently. And so it's not only just performance, right? The other thing is basically also the polyglot aspect, which is the attractiveness of GraalPython. So in the analytics, as you saw earlier, what you can do is you can have you have the main usage of Python, but then you can also analyze combining R and Python, for example. And also we saw an example of JavaScript in there as well. So it's possible to use different languages according to the characteristics and the specialization of the development team that you have got and things like that as well, right? So that's pretty much it. And the best way for you to actually look at it, or one more thing I wanted to share, is that we've got this interesting notebook that actually runs and shows you GraalPython in different areas. So this is if you can see this, it's a pretty interesting one. So it basically, what it does is for polyglot programming in GraalVM, you can use almost like a polynode, right? So you can run different types of languages, and within there, you start seeing the performance areas, but specifically how the different languages run. and you can run things like your GraalVM code and from Python and Ruby, R, and things like that. Get your polyglot sort of outputs. Run hello Java, print in Python and things like that with Java and JavaScript. And then also if you wanted to be able to sort of look at Python and do a conference sort of analysis of rows and so forth, you can actually plot and visualize that from Python as we saw in R, and then look at different areas and so forth. So this is kind of like integrating the polyglot function into a sort of notebook, and then you can run it like with multilingual polyglot style design and things like that as well, right? So just a sort of like a polynode and polyglot programming for GraalVM from a visual standpoint and things like that. But you can also run it from within the command line as I showed earlier and so forth as well. So that's basically 3 different areas, polyglot, performance, and update. And looking forward to seeing you guys on that community to learning more about GraalPython. And I hope in this 20-25 30 minutes you've learned something about it and it's been useful for you, and appreciate any feedback you've got as well going forward. So I'm open to questions you guys have, since we have some 5 minutes left, or maybe it's a bit over the time, but happy to take any questions you've got. All right, so thanks for joining. So this is obviously recorded. I will be sharing that shortly, and then you guys can have a nice sort of flow into some of these areas and things like that as well, and you'll be able to run this yourselves. I will upload the instructions on GitHub and some of the things that you can actually do accordingly going forward. So thanks everybody. Take care and have a nice day and have a nice PyCon conference. And thank you, Sammy, again, and the rest of the team there. I really appreciate giving us this opportunity to share some of the things that we're working on and so forth. Take care. Have a good day. Bye bye.
Bye bye. Thank you.
Thank you.